Hey guys, hello everyone and welcome to the channel and welcome to another video of single shot video series. In this series we are taking topics from chemistry and we are trying to sum up them in a single short video so that it gives you a quick revision just before your exam. So this video is about solid state chemistry. First of all, before starting the video, I would like to thank Karthik for providing all the slides. Thank you Karthik for providing these colorful and so precise slides for this particular video. A big shout out to you. And one more important thing, that if you are new to this channel and if you have not subscribed the channel, please do consider subscribing it. We have already covered topics like nuclear chemistry, polymer chemistry and surface chemistry in the previous single shot videos. So the link to the playlist is there in the description of this video. Please do check out those videos as well. Now, without wasting any time, let's continue with single shot video on solid state chemistry. Alright, so the first thing first, solids are generally divided into three broad classes. These are crystalline solids, non-crystalline solids and quasi-crystalline solids. Crystalline solids have very high degree of order in a periodic atomic arrangement. Practically all metals and many minerals such as common table salt, which is your sodium chloride, belongs to this particular class. Non-crystalline solids are those in which atoms and molecules do not organize in a definite lattice pattern. They include like glasses or plastics and gels. So all the other solids, they comes under non-crystalline solid. Now there are 7 crystal system which define a crystalline solid, can be considered as 7 crystal system, and they constitute to 14 Bragg lattices. Now these crystal systems are like triclinic, monoclinic, orthorhombic, tetragonal, hexagonal, cubic and rhombohedral. We'll get to know all these things in next slides. So here are the properties of the different crystal systems. These are the relationship between the axis. So A, B and C are actually the edge lengths of these cubic systems, and alpha, beta and gamma are angles of the system. So the table just explains you that how you can relate crystal system, different crystal system with the edge length and the angles. This table is very important. Sometimes a direct question is asked for 2 marks from this. So you should you should remember this table, you should know this table, right? Bragg lattices are basically 7 unit cell only, plus when you make them of different types, like the arrangement of atoms are also considered, they give you 14 Bragg lattices. So you can see that just the cubic system can arrange in 3 different arrangements. These are simple cubic, body centered cubic and face centered cubic. In the same way, tetragonal can exist in 2 forms. One is simple cubic or primitive, and the other one is body centered. Orthorhombic can exist in all the all 4 types of arrangement. One is primitive, then body centered, face centered and end centered. Then hexagonal has only one form, that is primitive. Trigonal also has one form, that is primitive. Monoclinic exists in 2 forms. One is your primitive and the other one is your end centered, whereas triclinic exists only in one form, that is primitive. So overall, if you count all of them, they constitute 14 lattice system, and these are called Bragg lattices. Now here in this slide, we'll try to understand the symmetry which is present in these crystal systems. So all the crystal system are mentioned in the first column. Then you have plane of symmetry, that how many plane of symmetry you have, then how many axis of symmetry we have, how many center of symmetries we have in them, and total how many symmetry elements we have. And at the end, point group is there. So it's very important to know about the point groups of different crystal system. Sometimes direct questions are asked from here, so you should know that what a particular crystal system has a particular point group. All right, so that should be known. Let's talk about unit cell. So unit cell is basically the smallest portion of the crystal lattice that shows 3-dimensional pattern in the entire crystal. So a simple unit, when it keeps on repeating itself, it is called unit cell. So crystal can be bought as of the same unit cell repeated over and over in the 3 dimension. There are 4 types of unit cells. One is primitive unit cell, then body centered cubic or body centered unit cell, then face centered unit cell and end centered unit cell. Primitive is denoted by P, body centered is denoted by, as you can see here, body centered is denoted by I. So body centered by I, face centered by F and end centered by C. So these are the letters to denote the unit cells. Now, as you can see here that this is how the atoms are going to look like. So in simple cubic, the atoms are like arranged only on the corners. In body centered, apart from the atoms on the corner, you also have an atom in the body center. In face centered, apart from the atoms at the corner, you also have atoms on the faces, center of the faces. Whereas in the end centered cubic, you have atoms on the corner. Also, you have atom on two opposite faces. Number of atoms per unit cell is very important to know. So in the primitive cell, there are total 1 atom per unit cell. Remember that all the atoms which are present on the corner, they contribute 1 by 8 atom per unit cell. Whereas atom in the body center, it constitutes 1 atom per unit cell. Whereas if you talk about the atoms on the faces, so they contribute half atom per unit cell. So considering the fact for primitive, since there are 8 atoms, you can count 1, 2, 3, 4, 5, 6, 7, 8. So 8 atoms into 1 by 8 will give it 1. For body centered cubic, 8 atoms on the corner, so 1 by 8 for them, and 1 into 1 for the body centered. Total atoms 2 per unit cell. Okay. Face centered mein you have 8 into 1 by 8 for corner atoms, and since you have 6 faces and each face gives you 1 by 2, so it is 1 plus 3, which makes it 4. So 4 atoms per unit cell. In end centered cubic, you have like 8 atoms on the corner, whereas only 2 atoms on opposite faces. So 2 into 1 by 2, that gives you 2. The next important thing is packing fraction. Packing fraction is it gives you the value, or it gives you the amount of space which is occupied in a particular unit cell. So it is given by formula Z into volume of atom divided by volume of unit cell, where for primitive your relationship between A and R. A is the edge length and R is the radius of atom. So A is equals to 2R, and the packing fraction comes out 0.52, or you can say 52%. Whereas for body centered cubic, the relationship between A and R is A is equals to 4 by root 3 R, and the packing fraction is 0.68 or 68%. Whereas for face centered cubic, the relationship between A and R is A is equals to 4 upon root 2 R, or 0.74 as the packing fraction, or 74%. Similarly, if you calculate for HCP, that is hexagonal close packing, the relationship between A and R is A is equals to 2R, and there is one more length that is called C, because hexagonal close packing will have two types of length, because it will be something like this, hexagonally packed. So that's why it will also have, apart from having the edge length which will be A here, you also have C. C will be the height. Okay, this is C. So the C is related as C is equals to under root 2 by 3 into 4R. Packing fraction here also is 0.74 or 74%. Whereas for the diamond cubic system, or for the diamond unit cell or diamond arrangement, here Z is equals to 8, means number of atoms per unit cell is equals to 8. Relationship between A and R is A is equals to 8R upon root 3, and the packing fraction is 0.34 or 34%. If somebody asks that which of the unit cell is highly packed, give your answers in the comment section. Tell me that which unit cell is highly packed. And the second question is that which unit cell has a lot of free space, or the most amount of free space. Tell me those questions answers in the comment section. Okay, so what are your question? Question number 1 is that which unit cell has or which unit cell is highly packed. Tell me in the comment sections. Whereas question number 2 is which unit cell has most vacant space. All right, so I would like to know your answers in the comment sections below. Okay, the next thing is to calculate density of the solid. Density of the solid can be calculated by this formula, Z into M upon A cube into Na, where Na is Avogadro number, A is the edge length, Z is that number of atoms per unit cell, M is the molecular mass. Everything is mentioned over here. There is one more thing called as radius ratio rule, or radius ratio for the ionic solid. So radius ratio tells you about the coordination number, that how many atoms are going to surround a particular atom. So the radius ratio is less than 0.155, then the coordination number is 2, the type of void will be linear. Whereas if the radius ratio is between 0.155 to 0.225, then the coordination number is 3, and the type of void is trigonal planar. If the radius ratio is between 0.225 to 0.414, then the coordination number is 4 and the type of void is tetrahedral. Whereas if the radius ratio is 0.414 to 0.732, then the coordination number is 6 and the type of void is octahedral. Whereas if the radius ratio is 0.732 to 1, in that case coordination number is 8 and your type of void is going to be cubic. And if radius ratio is 1 or greater than 1, then the coordination number is 12 and the close packing arrangement, or you can say CCP or HCP arrangement, is there. One very important point is written over here, that if there are n atoms in the crystal system, then number of tetrahedral void is going to be equal to 2n and number of octahedral void can be given as equals to n. Alright, now there are certain very important structures of some solid which you have to study. The first one is rock salt or NaCl. It has FCC array, means face centered cubic array of Na plus and Cl minus both. So sodium ions are also present in face centered cubic and chloride ion are also present in face centered cubic arrangement. Alright, coordination number is 6:6. This is how it looks like. Here all these blue dots are your chloride ions and red dots are your sodium ions. The next is ZNS, that is called zinc blende or woodsite structure. Now ZNS occurs in two common polytypes. These are zinc blende called as sphalerite and also woodsite. The two types have these features in common. What are the features? The first one is that the stoichiometry is 1:1. That means for every one zinc atom there will be one sulfur atom present. Coordination number of 4 in each of them, that means there is a 4:4 coordination ratio. For every 4 zinc atom, or in a unit cell there will be 4 zinc atom present and 4 sulfur atom present. Zinc blende is based on FCC lattice of an ion, whereas woodsite is derived from HCP array. In both the structure, the cation occupy one of the two types of tetrahedral holes present. In figure 1, you can see this is figure 1. Half of the tetrahedral void is occupied, and you can see that although there were possibility of 8 tetrahedral void, but just 4 of those tetrahedral voids are occupied. Here red color shows the zinc atoms, whereas blue dots are your sulfur atoms. The other one is your zinc woodsite. Here you can see that it is arranged in HCP arrangement, and you can see that all these blue dots are again sulfide atoms and the zinc is in the red balls present over here. Now there is a very good you can see the difference between both of them, zinc blende and zinc woodsite. So definition is that zinc blende is the cubic crystal structure shown by ZNS and woodsite is cubic crystal system shown by ZNS. Okay, both of them are same thing. Crystal system here is cubic, whereas in woodsite it is hexagonal in density. Zinc blende is high in density, whereas woodsite is low in density. Asymmetric unit, it has 4 asymmetric unit, whereas zinc blende has 2 asymmetric unit. Stability, thermodynamically zinc blende is more stable, whereas zinc woodsite is thermodynamically less stable. Let's talk about perovskite. Perovskite are compounds which have formula ABX3 type, where A and B are 2 ions and they should be different in size, and X is an ion which is generally oxide. Okay, so here if you can see, this is a very famous perovskite of CaTiO3 is given to you. Here all these white dot here shows titanium plus 4 ions which is present in the body center arrangement. Calcium plus 2 ion are present in the corners. So these are all gray ones are actually calcium ions. Okay, so these are present in the corners, and oxide ions are present on the face center. So these black dots are oxide ions. So that's how your perovskite looks like. The coordination number is in this way, that your calcium has 12 coordination number, titanium has coordination number of 6, whereas oxygen has coordination number of 2. So the coordination number of each element you should know in a particular perovskite. The definition you can read about it over here. And the Bragg lattice which they follow is simple cubic, and there are different typical ceramics which are there, like CaTiO3 or BaTiO3. They are different structures of them. Instead of calcium, barium can also come. There are two more important structures. These are fluorite and antifluorite. In solid state chemistry, fluorite structure refers to common motifs for the compound which have formula MX type 2 or MX2. The X ion occupy the 8 tetrahedral interstitial site, whereas M ion occupy regular sites of the face centered cubic. So you can see this is arrangement of fluorite, which is shown over here. So X occupies the tetrahedral voids, whereas M, that is metal, that occupies face centered cubic. Whereas antifluorite will be reverse of this. In antifluorite mineral with the crystal structure identical to that of fluorite, but with the position of the cations and anion reversed. That means cations will be present in the voids and anions will be present in the face centered cubic. Okay, so that's antifluorite. Example of antifluorite is Na2O. Example of fluorite is CaF2. Now the next thing is spinels. Spinels are any of the class of mineral with general formula Ab2X4 with X anion, typically either any of the oxygen family ligands like oxygen or sulfur arranged in a cubic close packed structure, and cation A and B occupying some of the octahedral or tetrahedral site. What are normal spinels? So if the negative ion forms FCC lattice, positive ions are present in the void. What are those voids? So A plus 2 is present in tetrahedral void, whereas B plus 3 is present in octahedral void. What is inverse spinel? So in the inverse spinel, A plus 2 is present in tetrahedral void, and both A plus 2 and B plus 3 are present in octahedral void. Whereas in the mixed spinel, the anions form the HCP arrangement and cations in 2/3 of the octahedral void. So that's your mixed spinel. How to identify normal spinel and inverse spinel, that has been taught very efficiently in coordination chemistry, and that can be done through calculation of crystal field stabilization energy in the octahedral field and tetrahedral field to find out whether the spinel will be normal spinel or inverse spinel. Alright, the next very important thing in your solid state chemistry is your X-ray diffraction or Bragg's equation. So XRD is an instrument which is called as X-ray diffractometer, and it's an instrument which is employed to determine the underlying crystal structure. So if you form any crystal and if you want to understand that how the crystal is going to look like, so XRD is an instrument which is going to do that. So XRD is a non-destructive technique which can be conducted at room temperature and pressure, and it uses Bragg's method to do that. Bragg's method is 2d sine theta is equals to n lambda, where lambda is the wavelength of light which is being used, which is here X-rays here. D is your interplanar distance. Theta is the angle at which the light falls on the crystal system. So here n is the order of diffraction, lambda is the wavelength of light which you are using, d is the interplanar distance, and theta is the angle of diffraction. Now D, HKL and the Miller indices and V's indices. So this is a particular thing which you all should be able to understand, and D is nothing but interplanar distance. The distance between two planes of a solid is called as interplanar distance, that is calculated as D, whereas Miller indices are represented as H, K and L. First of all, let's talk about V's indices. So V's parameters state the relative number of units at which phase cuts each axis. As an example, if let's say 2A, 2B and 1C indicate that the phase intercepts at A and B axis as twice as many as your C axis. So if you have A, B and C axis, so if the phase or the plane cuts A and B axis twice as the distance of the C axis, then that is given as 2A, 2B and 1C. They are predecessors in the Miller indices. Now the phase that has V symbol 3A, 3B and 1C, that means it is going to cut the A axis, B axis thrice more as it is going to cut the C axis at a particular distance. Okay, so they can be represented in this way. Now to convert these V's indices into Miller indices, what you have to do is, first of all, you have to divide every of them. You have to take reciprocal basically of all of them. So 1 by 3, 1 by 3 and 1 is going to be the reciprocal. Now you have to make them a simple whole number, and for that you are going to multiply with 3. So if you multiply all of this with 3, so 1 by 3 into 3 will become 1, 1 by 3 into 1 will again become 1, whereas 1 into 3 will become 3. So this is going to be the Miller indices. So Miller indices is 1, 1, 3. So how to convert these indices into Miller indices? By taking reciprocal and then multiplying with a number to make it a simple whole number ratio. And they are represented as H, K and L. Now to calculate your distance or to calculate your interplanar distance based upon your different Miller indices values, H, K and L are Miller indices value, A, B and C are different edge length. So the formulas are different. In the cubic system, the formula is pretty simple, like D is equals to A upon under root h square plus k square plus l square. This is the basic formula which we use generally, but that is only for the cubic system. If the system is orthorhombic, you use this formula, that is 1 upon d square is equals to h square upon a square plus k square upon b square plus l square upon c square. In tetragonal system, it is 1 upon d square is equals to h square plus k square plus l square into a upon c whole square into 1 upon a square. Now, condition of the unit cell to get X-ray diffraction. So this is very important thing, or you can say this is a shortcut trick which can tell you that whether the system is what type of system, what type of crystal system it is. So for primitive cell, all the values of H, K and L are allowed, whereas for the body centered cubic, only those H, K and L, that is only those Miller indices are allowed whose sum gives you an even number. So if H plus K plus L gives you an even number, then only it falls under body centered cubic. For face centered cubic, all the values of H, K and L should be either they should be even or they all should be odd. Then only it will be considered as a face centered cubic. At the end, we have a slide where we are given with different planes, or you can say different systems, crystal systems, and here these planes, like the colored planes, are shown, and corresponding Miller indices is written to you. So you can practice different Miller indices looking upon the planes on the screen right now. So that's it for this video, guys. That's it for the single short video revision of solid state chemistry. I hope the video helped you in your revision, and I will see you guys in the next one with another topic. Till then, have a great day. Bye bye. Take care. Hey guys, so I teach live on Uncademy Plus platform. Here I teach for the CSIR UGC NET category, and you can follow me over here for regular classes. You can access my free classes as well as my paid classes on this particular platform. The classes which are free, you can get that under the section of special classes, whereas in order to access my paid classes, paid live classes, you have to take Uncademy Plus subscription. So do make sure that you take the Uncademy Plus subscription to access all my paid classes, which are quite organized. The whole syllabus is being completed over there, and the classes are quite regular over there. So make sure that you take Uncademy Plus subscription by using my referral code, that is N_Huda. That's it for this. Thank you so much.